Good evening, sir.
Yeah, good evening. Okay, your classes have not started yet, right?
Yes, sir, they haven't. But actually, we will have to go to our school. I mean, the other school that we're associated with Alan. So I'll have to go in the mornings. But otherwise, yeah, I have more than half the day to myself. So I
Are you
can.
doing the physics stuff that I sent?
Yes, sir, I did try a few of them, but no, but this week I've been focusing on solving the question papers.
What question papers?
The SRG papers that we had. Like the other questions which I didn't ask you for doubts, I was trying to solve them on my own.
Are you doing your revision for 11th grade physics?
Yes, sir. But I have to still do more for the rotation chapter.
Okay, these questions that you have sent are from where?
The SRG paper, which I couldn't get after trying again.
Okay, uh, consider the equation 8x power 4 minus 16x cubed plus 16x square minus 8x plus a. The sum of all non-real roots of this equation can be. For a fourth degree equation, we know that the real roots, it could have zero real roots or two real roots or four real roots, right?
Yeah,
Because all the coefficients of the equation are real, so imaginary roots will occur in pairs.
yeah,
So
either four imaginary or two. So, yeah.
we have to find sum of all non-real roots of this equation. So you have to first figure out how many non-real roots, and then you can find the sum. Uh, so sum of all the roots is obvious, it is 2.
Yeah. So I took one case where all the four are imaginary, so I marked two as one answer for this.
So sum of all roots is 2. You have to figure out what other possibilities are there, right?
Yeah. So, sir, when I tried solving this question, what I did was I first took case one as all the four roots are imaginary. So then I checked the sum of roots as two, and then I had to even confirm whether the roots taken two at a time, three at a time, and so on also are real numbers. So when I checked it for four roots, I realized that all of them will be real, even if you take it two at a time and so on. So that's how I confirmed with the options.
What is the confirmation there? What have you confirmed?
Like basically if all the four roots are irrational, they'll be in pairs, conjugate pairs, and even the roots taken two at a time, three at a time, and so on also have to be real numbers based on the equation. So that is possible if all the four are imaginary. So that's why even two is possible, is what I figured out. But I wasn't sure of one and half, the other two
How will
options.
you confirm that when you don't know the roots? Like, how will you confirm alpha, beta, gamma, 3 at a time is coming out to be real?
I just took certain cases like my own roots.
Why are you wasting time doing such things? Like, how would you be sure of this? You have to my own roots as
Like, or I just took a few conjugates and saw whether it was coming as a real number or not, and it did come. I didn't spend too much time on it. I just spent, I think, 2 more minutes on it.
you cannot confirm this based on just a feeling and one random choice of your conjugate roots.
Yeah,
That's not a confirmation. That's just one case.
yeah, that's the case.
There is no guarantee that this has to be real.
Yeah,
You have to focus your attention on other parts of the problem where you can try to figure out what is actually happening instead of doing random guessing.
yeah. I did try d greater than zero, but this is a, what do you call, a biquadratic
How will you try d
equation.
greater than 0?
I wanted to try, but it didn't come because it's a biquadratic.
The equation you have to analyze on the basis of how the graph will be. The this this graph, obviously we can see that minus infinity and plus infinity, the whole function tends to infinity. So
Yeah.
the graph can be large, can be like this when it has no real roots, or it can be like this, which is two real roots, or it can even be like this, which is four real roots.
Yeah.
These are the three cases that are possible. We have to check which case is actually happening here and then figure out what to do.
Okay.
These are the three types of biquadratic graphs that you could possibly get. We have to check which is actually happening.
Yeah.
If you want to understand which one is actually happening, you will have to take the f dash x derivative, which tells us how the graph increases or decreases. So
Okay.
here f dash x would be equal to, this is my f dash x, which again, this is 8 times 4x cube minus 6x squared plus 4x minus 1. You have to understand the nature of the f dash x function. F dash x function
Mm.
will be different in different cases. Like if the f dash x function is, like if you put some values here, you will realize whether it is constantly increasing or it can have one real root or three real roots.
Okay. So should we differentiate it again and check it with respect to the quadratic?
F dash x can have one or three real roots. If it
Yeah.
has one real root, it's a constantly increasing f dash x. That means f dash x has one real root. What it means is there is one point of maxima or minima for f of x.
Yeah.
That would be case 2.
No, okay. Yeah.
How is that case 2?
Because in case 2 there are two real roots, and what you said was if it has one real root, the other, what do you call, the other two have to be imaginary, and then we'll be left with another real root because it's a biquadratic equation.
You are not focusing on the right things. F dash x is 0, has only one real root. That means there is only one point where the derivative is 0. That means when you do derivative is 0, that gives us maxima or minima of f of x.
Yeah.
So how many points of maxima or minima of f of x are possible if f dash x is equal to 0 has one real root?
How many points of maxima and minima? Okay. For, basically it's that graph, right? Like case 2. It's an upward curve.
Why is it case 2 here?
um, I have a different reason. Like it's because first we differentiated the biquadratic equation to get a cubic, and from the cubic we got to know that there's only one real root and two imaginary roots. So therefore, the other root, the fourth root of the biquadratic, has to be a real root only. So That's why it will intersect at two places on the
What are
x-axis.
you, how are you connecting roots of f dash x to roots of f of x? What is the connection?
If the cubic has only one real root, the other two roots are imaginary and they are in conjugate pair. So that basically means that the biquadratic has two imaginary roots and two real roots.
How do
That
you know that? That's what I want to find out the reason. You're just making a statement. Give me a reason. That means that is not a reason.
okay.
If f dash x is equal to 0 has only one real root, how do you know that f of x is equal to 0 has two real roots?
As you said, if f dash x is equal to 0, it depicts the maxima or minima of f of x. So it will cut the x-axis at basically two places will show the maxima or minima.
No, two places is not maximum minima. There is one maximum minima if it has one
Sorry,
root.
I meant there's one maxima and minima, and it will cut at two places when you draw the graph.
That is the real reason. If it has one maximum minima, it can only take case 2 then.
Yeah, yeah.
It could also be case 1, but
This one?
we can check that with our value of the maximum minima.
Okay,
It is definitely not case 3 where there are multiple maximum minimas.
okay, yeah, that's right.
If f dash x is equal to 0 has only one real root, we are only stuck in case 1 or case 2.
Yeah, that's right.
So now we need to understand how many roots this one has. So
Mhm.
we can see when this becomes 0. So you can take different values of
Yeah,
x. For example, if x is 0, f dash x is coming out to be -1. And
yeah,
if x is 1, it will become 4 minus 6 plus 4 minus 1. So 8 minus 7. So it is +1.
yeah.
So that means the sign has changed between 0 and 1. F dash
That's
x has changed its sign between minus to positive. So there is a root between 0 and 1 for f dash x,
yeah,
right? We can
yes,
also check the values at, if you take 2, obviously it becomes positive. So as if you increase the value of x now, it will remain positive because x cube will be bigger than x square.
yeah. That's right.
If you take the negative values, for example, x is equal to -1, we will get -4, -6, -4,
Yeah,
minus
the
1s.
negative is yeah,
So it is negative, and if you take -2, also negative. Okay. So for all negative x's, this term is negative, this term is also negative, this term is also negative. So every term is negative, right?
yeah,
So we can easily see from here that f dash s clearly has only one root between
one.
0 and 1,
Yeah,
right? So now we know that there is a maxima minima of f of x between 0 and 1.
that's right. Yeah,
So at 0, the value of the function is -8. At 1, the value of the function is 32 plus 32, 64, minus 48 minus 8, 56. So plus 8. So the value of the function is between -8 to +8. Okay. So we are, oh no, I have
wait,
taken
how
the
is
wrong thing. We have to take the value of the function here.
yeah,
So we
yeah,
know it
that's
has a maxima minima between 0 and 1.
yeah.
And
But
okay, so we can basically figure out it should be a minima because we can take double derivative. Double derivative is 12x square minus 12x plus 4. And
hmm.
at points between 0 and 1, this value is positive. So
Yeah.
it is a minima. Between 0 and 1, any value, if you take 0, you get 4. 1, you get 4 also. So f dash f double dash x between 0 and 1 is going to have a positive value. If you take half, for example, what is happening? 12
Half.
by
Okay.
4 minus x square is less than x, so it is negative, but it will not be too negative because there is a plus 4 there.
Yeah, there's plus
This
2.
is a minima, so we need to now understand which case it is, whether it is the no real roots case or whether it is the two real roots case.
Yeah.
So we have already excluded the case 3. Case 3 is not coming in this
Yeah,
equation.
it's not coming.
So these are the two possible cases, and we have to now think of, okay, so that depends on the value of A clearly. And for certain if the minimum value is bigger than if the minimum value is bigger than 0, it is the case of 0 real roots, right?
Yeah.
So the point of maxima minima of this function, or the root of this equation, if I can find, then it will be better.
Yeah, we don't know
So
the root yet.
4x cube minus 6x square plus 4x minus 1. F dash x is equal to 4x cube 4x minus 1. We have to find when it is equal to 0. We know it happens between 0 and 1. So when is it equal to 0? Okay. At 0, the value was minus 1. At 1, the value was plus.
Yeah.
So we can try to find the value at f dash of half. What is half? So that is 4 into 1 by 8 minus 6 into 1 by 4 plus 4 into 1 by 2 minus 1. So that is half minus 3 by 2 plus 2 minus 1. It is minus 1. It is 0. Okay. So that is good because
Yeah. Okay.
it is 0, right? Plus 1
Yeah,
and
it
half.
is 0.
So we know the root now. F dash half is 0.
Yes, yeah.
If you know f dash half is 0, fx is minima, fx is equal to 0 has minimum at half, right?
Yeah.
If it has minimum at half, now we will check the value of this minima, and that is coming out to be 8 into 1 by 16 minus 16 into 1 by 8 plus 16 into 1 by 4 minus 8 into 1 by 2 plus a. This is half minus 2 plus 4 minus 4. So
Yeah.
a minus 3 by 2. A minus 3 by 2 is the value of the minima. Now, for different values of a, you will get either, if a is greater than 3 by 2, you get no real roots.
Okay. Yeah.
No real roots means sum of all the non-real roots is equal to 2.
Equal to 2. Yeah.
If a is less than 3 by 2, you get two real roots, right?
Yeah.
Because the graph is going below the x-axis.
Correct. Yeah.
A is less than 3 by 2, f of x graph is like this. The minimum is at x is equal to half. And the
Yeah.
value was coming out to be a minus 3 by 2, the value
Minus
of the
3 by 2.
minima.
Yeah.
So now these are the two real roots, right? Alpha
Yeah.
and beta. These are the two real roots. We don't have to find the sum of the real roots, right?
Yes, yeah.
We can see from the graph in this case that the real roots are symmetric about the line x is equal to half,
That's
right?
really good. Yeah.
So it is obvious that alpha plus beta, the real root sum is equal to half.
Oh, yeah, that's right. It's
So the sum
symmetric.
of
Yeah.
the non-real roots is 3 by 2 because
Okay.
the total sum is 2.
Total sum is 2.
So the non-real root sum is 3 by 2. So that is the case in the other case. Sum of all non-real roots. Hmm. I don't know what else you can do. I don't think there's anything else you can do. These are the two cases. Uh, the other type of graph would have been when there are multiple maxima minimas for f dash x. But that is not happening in this case.
Yeah, that's right.
There could be a situation where it was like this, where there were four real roots, but it's not happening because when you check f dash x is always negative for x less than 0. And f
Yeah.
dash x is changing sign between x 0 and 1, and after 1 it is always positive.
Okay.
So that's what you have to do here. You have to figure it out like this. You have to find maxima minima of the curve, think about the nature of the graph, and then try to do it.
Okay.
Okay. Next one is
So, sir, the answer cannot be 1, right?
we are not getting one unless we have made some calculation mistakes.
Okay.
You have to check
Because, yeah.
because
I,
what?
because I just checked now, and according to the answer key, the answer is 1 and 2.
We are minus 16 square. At x is equal to half, we had 32x cube minus 48x square. At x is equal to half, this is 4, 20 into 0. F dash half is 0. So the minimum value is happening at x is equal to half. And at x is equal to half, if you take the value of
Yeah.
this function is 8
By
by
2.
16 minus 16 by 8 plus 16 by 4 minus 8 by 2 a
Yes.
16 by 4 and this cancels. You have 1 by 2 minus 2 minus 3 by 2 plus a.
Yeah, A minus 3 by 2. Yeah.
If a is greater than 3 by 2 and the minimum value is above 0, you have the first case. If
Yeah.
a is less than 3 by 2, the minimum value is at half. Minimum value of the function is at half and it is negative. That means there are two real roots which add up to half. Two real roots add up to half. The remaining non-real roots will be 3 by 2, not anything else.
Yeah.
The answer is wrong if they're saying it is 1.
I don't know why, but when they took the condition for A less than equal to 3 by 2, they're telling that the sum of imaginary roots is 1.
Why?
I just send a pic. Yes, I sent it. In Zoom chat.
It's wrong. Clearly, it's wrong. If A is less than 3 by 2, the graph is having one minimum. This is the graph.
Yeah, they just true.
How is this? How is the sum of these two roots going to be anything other than half?
Yeah, that's right.
There are only two real roots. The roots are symmetrical about the half
Yeah.
point.
Yeah.
Um, are they symmetrical about the half point?
Shouldn't
But
they
it's
be?
not
Because
necessary. One second. It's not necessary because it's not a parabola.
oh yeah, it's
It's a
the
biquadratic. So
biquadratic. Yeah.
there is a minimum at half. It is not guaranteed that the graph will be symmetrical. So if the graph is not symmetrical, then we don't know the sum of the real roots then.
Yeah.
Uh, okay. Um, so they are doing it by a different way in which they are trying to take x square minus x as t.
Or converting it into a quadratic. Okay.
Square minus 8x power 4 minus 16x cube.
Yeah, divided by 8 all both sides.
Can say that this is x square common x square plus 2 minus 2x minus x common. Yeah, that is not what they're doing. Uh, they are writing this as
Yeah, they
x
completed the
square
square.
minus x whole square.
Yeah. The 2x square to just x square and the other x square goes with minus x. Minus a by 8. Yeah.
T square plus t plus a by 8 0. T is x square minus x. So this graph they have tried to draw. T square plus t plus 8 equals 0. The quadratic, the discriminant is root over 1 minus 4 into a by 8. 1 minus a by 2. So this quadratic If you, or we can have done it by completing the square on t square plus t plus 1 by 4 plus a by 8 minus 1 by 4 is
Hmm.
0. This is t plus half whole square is equal to 1 by 4 minus a by 8. So t will have real values if a by 8, this is positive. So 1 by 4 minus a by 8 is greater than 0, then t plus half has real values. So 1 by 4 is greater than a by 8 is less than 2 now we are getting. A is less than 2, then this has t plus half has two real values. And then you have to check x square minus x.
Okay.
But still, like, how do you get it so easy? How are they suddenly getting it? There is no logic given.
How did they get the minus 3 by 16 part?
They are trying to find maximum minimum of this t square plus t plus 1 by a by 8. Uh,
Okay. So they found the minima.
it is still not very clear what he has done.
Hmm.
2t is equal to minus half.
Yeah,
At
that will
t is
give
equal to minus half, you have 1 by
t.
4 plus minus half.
Oh, we have
So
defined t as x square minus x, so we have to equate it to half.
it's not making much sense, but trying to find the non-real roots of this square plus t is minus a by 8. The roots in terms of t can be written, it will come like this, something minus 1 plus minus this by 2. Then you have to think of the roots in terms of x.
Hmm. Yeah.
So we have to find the roots in terms of x now. So x square minus x is equal to this thing. So if this thing is imaginary, the roots in terms of x are also imaginary, right?
Yeah. I okay.
We have
Done that. Please.
square minus
So,
x is equal to minus 1 plus minus root over 1 minus a by 2 by 2. If if this thing is imaginary, the two roots of x are also imaginary clearly.
yeah, that's right.
And the sum of the roots of those imaginary roots will be 1.
Okay.
Because look at the quadratic x square minus x
Yeah,
minus
it's one.
sum of the roots is 1 of those
One.
imaginary roots.
Okay.
If this thing is real, the roots are real.
Okay, then. Oh, okay.
So we don't have to worry
Don't
about
need to.
those sum, right?
Yeah, we don't need to.
We only have to worry about the two non-real sums,
Yeah.
and which in which case it will be one because you can just look at this equation.
Okay.
I don't know what he's doing with the graphs and all. That doesn't make any sense.
Okay.
He has made a quadratic in t, and then from there we are figuring out that roots of t will be something like this and roots of x will be something like this.
Yeah, we don't need.
We don't need to do the case where it is all four roots are real. We already know the answer for
We
that.
already know it's, yeah. And
Only
so
in
even
the
when
case,
I substituted t's value as half, I didn't get it as minus 3 by 16 plus a by 8. I got it as minus 3 by 4 plus a by 8. So there are, I think, a few mistakes.
I don't know what he's doing, but you can just
Yeah.
find the answer as half based
One
on
and
that quadratic.
yeah, I got.
Okay. A circle having center C passes through 1 comma 2, touching the lines 7x minus y equals to 5 at A and x plus y plus 13 at B. P is point of intersection of both the tangents. Both tangents. Obviously, these lines are tangents to the circle.
Yeah.
So P is the point of intersection of A intersection B. And we have to find out some information about quadrilateral ACBP, area ACBP, and radius of smaller circle. So there are obviously, if you have two lines and this is the point of intersection P, you can have a bigger circle and a smaller circle,
Yeah.
right?
Yeah, that's right.
The circle could be centered here or centered here. Both are possible. You have to find the, if this is the situation A and B and C, you have to find the possible values of the area of the quadrilateral ACBP. It could be like this also.
Yeah, yeah.
That's why there are two different possibilities. And you also have to find the radius of the circle,
Yeah.
smaller circle. And they have said that it passes through the point, circle passes through 1 comma 2. Find this point. That point will be
I
8x plus 8 equal x is minus 1
yeah.
and minus 13 plus 1 minus 12. So the point P is minus 1 comma
Minus 1.
minus
Minus 1.
12, right?
Yeah.
Minus 1 comma minus 12.
Minus 12. Yeah.
Okay. If this is minus 1 minus 12 and A and B are unknown, circle radius is unknown, but the circle passes through 1 comma 2. The possible area of ACBP, this is R, this is R, uh, this is root S1 and root S1, right?
Yeah.
area of the ACVP is twice of the area of these triangles, which are congruent.
That's right. Yeah.
So half into root S1 into R is the area of this triangle. So area of this quadrilateral is root S1 into R, right?
Yeah, that's right.
The circle having center C passes through this, touches these two. Okay, point P. Okay, so hmm, so
So
we
what
have
I
to.
did for this is that we know that the center of the circle will lie on the angle bisector of the two lines. But after that, I wasn't able to get how to solve it. I did that and I got an equation for the center, but after that, I wasn't able to find the radius.
This is clearly a family of circles question. You have to look at the different situations in family of circles. Um, Find an equation of a family of circles such that it passes through a fixed point and is tangent to two given lines. That's the thing you need to know. So,
Okay.
um,
So do you want me to write it in the form of S plus lambda L?
no, you have to know the theory for how to find the family of circle equation. It's not S plus lambda. This is more specific because you have two lines given which are tangents, and you
Yeah.
also have 1 point given. If you open your book, you will have results in your Allen book for family of circles.
Yeah.
Check the results in family of circles. There will be a result for such a case.
Okay.
Mm, what we can say is, in general, I mean, you should check the results. There will be a better solution which will be faster using the family of circles results. Do you have the
Yeah.
Allen book with you?
Yes, sir, I have it.
Check the family of circles section.
Yeah, I'm doing that. There's one equation for the family of circles passing through the point of intersection of a circle S is equal to 0 and a line L is equal to 0. And it's given by S plus KL equal to 0.
That's not what we need.
We need, yeah, point of intersection and a line.
That is not what we are doing. Line and we have circle and a tangent line.
Yeah, that's the thing.
And circle passes through a point. Is there any other result given?
Um, Equation of family of circles touching a fixed line y minus y1 is equal to m into x minus x1 at the fixed point x1 y1 is x minus x1 whole square plus y minus y1 whole square plus k into y minus y1 minus m into x minus x1 equal to 0. It's for tangency.
So we can say that the equation of family of circles, the fixed point is -1, -12.
It should be tangent at that point as well.
It is tangent at the point, we don't know the point of tangency.
Yeah, we don't know the point.
Okay, we'll do it in a different way then. If the circle equation is in general written as x square plus y square plus 2gx plus 2fy plus c equals 0, we know several things. It passes through 1 comma 2, and the point here is -1 -12. So we know that, we'll do it on the next screen. Square plus y square plus 2gx. This circle passes through 1 comma 2.
So 1 comma 2 is the point of tangency for 7x minus y is equal to 5. I just realized. Sir,
Okay.
I got how to solve it, but without the family concept.
If 1 comma 2 is this point, the question is over.
Yeah, it's over. It's done.
We know root
And that is,
s1, and we can find radius easily.
yeah, it's done.
We know root s1 value,
Yeah, we
so
do.
the required area is root s1 into r.
Yeah,
This distance is clearly 4 plus 14 square, so root 200.
root 2. Yeah,
And 1 comma 2 and fine. So we can say that,
we can just say it lies on the angle bisector of the two lines. And then we'll get two relations for the center. One relation is the one that we get from angle bisector equation, and the other relation we can just use the slope form, because we know the slope of 1 comma 2 from the center is what do you call, perpendicular to the tangent slope of 7x minus y is equal to 5. So we'll get two relations.
we know the slope of this, we know the slope of
Yeah,
this.
yeah, we can solve it. I'll
We know the tan theta for this line. Tan theta is slope with respect to x-axis, we know. Okay. And we know slope of this line then. The slope is
yeah,
-7 by 7, and the slope is -1 by 7. 7 and -1 by 7. Um,
sir, I got the answer now to the question.
how?
um, we know that the center lies on the angle bisector of the two lines. So I wrote the equation of the angle bisectors as 1 comma 2 and I took the center as h comma k. So then I got two equations for the center.
One from the
One of the
slope.
and yeah, and then we also know the slope thing. Like we can take k minus 2 into h minus 1 is equal to minus 1 by 7.
So you are getting center as what then?
I'm getting two centers. I'm getting it as 29 comma minus 2 and minus 6 comma 3.
Two centers are for the two different circles. If
Yeah, I'm getting two.
you'll get the radius values, you'll get the area of ACBP.
Yes, sir. Yeah. We just missed that that point was lying on 7x minus y is equal to 5.
Hmm. Then the next one is let AB, which is y is equal to x, is a chord to y square plus 4x equals 4. P is any variable point on the ellipse. Square plus 9 minus 9 equals 0. Theta 1 and theta 2, maximum and minimum values of area of triangle ABP. Some values. We have to find possibly theta 1, theta 2 values and the ratios and stuff like that.
Yeah.
So y is equal to x is a chord of this and AB is the chord. So this is minus 4x plus 4. Y square is minus 4 times x minus 1. This is my parabola. If you put y is equal to x, you'll get the points A and B. So you'll get x square plus 4x minus 4 is 0. And this becomes
Yeah.
basically x plus 2 whole square is equal to plus minus 2 root 2. So x is equal to minus 2 plus 2 root 2 or minus 2 minus 2 root 2. And x is equal to
Yeah.
y. So the points A and B are known, right?
Yeah. That's right.
So what is the problem? You just take a parametric point on this and
I
find the area.
I did this, like I got minus 2 plus 2 root 2 and the other also. But I wasn't sure how to get the minimum area. Like I tried
That's
doing
super
it
easy. You just
without
need to
using
take a
calculus.
parametric. How will you do without using calculus?
Like I
You
wanted
have
to
to
see
use
whether I can observe it.
calculus. You have to use calculus. That's the best way to do it.
Okay.
The point will come in terms of a cos theta b sin theta here.
Yeah.
ABP triangle will, area of the triangle will be a function of theta. There is nothing difficult in this question. You just have to use calculus. Who is asking you to not use calculus?
Yeah.
You have to take a parametric point here on the ellipse. It will be 3 cos theta and 4 plus sine theta, right?
Yeah.
Area of the triangle can you find in terms of theta now?
Yeah, you can.
You know the
Um,
area formula will come in terms of
yeah,
theta. You just have to find maxima and minima of this function.
fine.
Nobody is asking you to not use calculus. The question
Yeah,
is
yeah.
designed for you to use calculus. It's a straightforward question. There's nothing mysterious here.
Yeah, I'll try this then.
The center of a circle passing through the center of a circle
This was a
passing
bit ambiguous.
through foci of a hyperbola and the points at which the tangent at center of a circle passing through the foci of a hyperbola and the points at which tangent at 6 comma 2 root 3 meets the tangent at the vertices. The tangent at the vertices. All of this is about the hyperbola. You have to find the equation of tangent to the hyperbola at this point, which is clearly x into 6 by 9 minus y into 2 root 3 by 4 equals 1, which is 2x by 3 minus y root 3 by 2 equals 1. This is the tangent at this point. The
Yeah,
hyperbola is like this. We have to also find tangents at the vertices. The vertices are
yeah.
these points. So
It's x is equal to 3 and x is equal to minus 3.
to find the tangent at the vertices, those
I,
equations are going to be simply this.
yeah,
The point of intersection of this line and this line with this line will give you two different points. If x is equal to minus 3, you get minus 2 minus y root 3 by 2 equals 1. So 3 y is equal to minus 3 into 2 by root 3. So minus 2 root 3. One point is minus 3 comma minus 2 root 3. Another point is when you put plus 3 here, you get 2 minus this. So 1 is equal to this. So 2 by root 3, right?
yeah, minus 2 root
3
3 and
comma. This is what you're
but
getting.
yeah, but
These are the 2 points where the tangent meets.
yeah,
Also, the circle has to pass through the foci. What is the focus of this hyperbola?
root 13 comma 0 and minus root 13 comma 0.
Centricity is this, so it is
Yeah,
root
root 13
13
and
by 3, and focus will be plus minus AE, so it will be root 13 comma 0 or minus root 13 comma 0.
yeah,
If you have 3 points, can you find the circle equation passing through those 3 points?
you can, yeah, but
But what?
oh, I misunderstood the question.
The center of a circle you have to find which passes through 3 points, one focus and the
Yeah,
two
got
points that you get from here.
yes, sir. Yeah, I
You have two options for the third point, but these
yeah,
two
got
points are fixed.
yes, yeah.
Anybody, if they are given 3 points, you can totally find the equation of the circle.
I did that, but I think I misunderstood the question.
This will give you one answer, another answer will come when you take minus root 13.
Yeah, I put it in the general circle equation and I found the value of c from there, and I even got g's value, but I was getting the incorrect value for f. But I'll try it again.
The question is about finding equation of a circle passing through 3 points. The 3 points are given in a convoluted way.
Yeah, yeah,
That's it.
yes, sir. Yeah, I'll do it.
Let a square plus 1 9. Number of integers in the range of okay, a square plus 1, b square plus 1, c square plus 1 equals 9. Number of integers in the range of this. Okay. All of these three quantities are positive, so we can apply A and GM. So we can say that a square plus 1 plus b square plus 1 plus c square plus 1 by 3 will be greater than equal to the cube root of the product, right?
Yeah, that's right.
Cube root of 9. So we know that a square plus b square plus c square plus 3 is greater than equal to 3 times cube root of 9. Hmm. So we have a square plus b square plus c square is greater than equal to, this is 3 into 3 power 2 by 3. So 3 power 5 by 3. 3 power 5 by 3 minus 3. We have this. We have to find the range of this. So AP plus BC plus C.
I tried something like completing the squares, like I expanded this multiplication, but I could not get to anywhere.
Square plus 1 square plus 1. ABC belong to R, okay? Hmm. Yeah. A square plus 1 is like saying A plus I, A minus I, B plus I, minus I equals to 9. So if your f of x is x plus I into x minus I, we are finding f of A, f of B, f of C. A, f of B, C product is 9. So We have to. We might have to do some expansion. You know, x square plus one, b square plus one is equal to 9. We know that a square plus 1 is greater than 2a, greater than 2b, greater than 2c. We can say 9 is greater than 6 abc, 8 abc, right?
Yeah.
We are getting abc is less than equal to 9 by 8. We have also gotten a square plus b square plus c square is greater than equal to 3 power 5 by 3 minus 3. We have to find out AB plus BC plus CA. So AB plus BC plus CA is equal to A plus B plus C whole square minus A square plus B square plus C square.
By 2, yeah.
We have to get somehow A plus B plus C whole square, an estimate of that from here.
Yeah, that's right.
Hmm.
So expanding also doesn't work. I tried that.
All the three numbers are bigger than 1 and the product is 9. Hmm. How can we arrange the product to look like this? A plus B plus C I need somehow. Um, C square plus 1. If we, yeah, I'll have to think about it. I don't know, right? I'll have to try it out. Uh, I'll attempt it and let you know.
Yes, sir. Yeah.
Fine. That's all for now then. We'll continue next class.
Yes, sir. Yeah. Thank you,
Try the
sir.
sheets that I have given for physics. Try those.
Yes, sir. I will try them.
I'll let you know if I get the answer to this one.
Yeah.
Fine. I'll see you
Thank
next
you.
time.
Yeah.